In this lecture, we are going to finish the registration form by submitting the data to our endpoint. Up until now, we've been using Postman for sending the request. Most users will probably want to fill out a form as opposed to downloading a program for registration. Let's finish the form. In your editor, open the frontend.js file. Earlier, we left off with rendering a message to the browser. This message will inform the user that their registration is in progress. After rendering the message, we should start initiating the request. First, we need to grab the form data. At the bottom of the function for handling the submission, create a variable called form data. The value for this variable will be an object. Inside this object, add a property called username. The value for this property will be the signupForm.querySelector function. Inside the form, I've given each input an ID. For the username field, the ID is the following, #SUName. We're selecting an input element. Input elements have a special property for extracting the value of an input. After selecting the input, add a property called value. The value property will contain the value from the input. We are going to do the same thing for the email and password. Add a property called email. The value for this property will be the following, signupForm.querySelector SUEmail.value. Lastly, let's add a property called password with the following value, signupForm.querySelector SUPassword.value. The names of our properties are important. The endpoint we've created will be expecting our data with these property names. Otherwise, our request will be rejected. Our data has been prepared. It's time to initiate the request. JavaScript has a special function for sending a request without refreshing the page. Below the object, run a function called fetch. The fetch function has two arguments. The first argument is the URL. In the previous lecture, we injected a variable with the URL for the custom endpoint. The name of the variable was called upAuthRest. This variable is an object with a property called signup. The second argument is optional. It's an object of configuration settings for the request. For this request, we're going to modify the default configuration. Pass in an object. Inside this object, we are going to add a property called method. The value for this property will be post. This property will allow us to change the HTTP method of the request. By default, the method will be set to GET. However, our endpoint is expecting a POST request. After changing the method, let's add an object called headers. As we've learned, HTTP requests can have a header and body. The header section of a request can contain useful information on the request. We can add or configure existing headers by adding properties to this object. Inside this object, let's set the content type header to the following value, application/JSON. By default, a request is sent as plain text. The endpoint is expecting JSON data. If we were to send the data as plain text, we may receive errors. To avoid this issue, we can change the content type header. This header describes the type of data or file sent to a server. The value for this header must be the MIME type of a file. For this example, we are setting this header to application/JSON, which is the content type for JSON files. There's one final property that will be added to the object. Below the headers property, add a property called body. We must send our data inside the body of the request. Before we do, the form data must be converted into a string. The value for this property will be the following, json.stringify form data. The JSON object is defined by the JavaScript language. It contains useful functions for interacting with JSON data. In this example, we are using the stringify function for converting a JavaScript object into a string. The string will be a copy of the form data object. We cannot send objects with the fetch function. Therefore, we must convert it into a string for compatibility. We're almost finished with the fetch function. There's one final step. This function is asynchronous. JavaScript is an interesting language. There are two concepts known as synchronous and asynchronous programming. Synchronous programming is when one line of code is executed at a time. Throughout this course, we've been writing synchronous code. Take a look at this example. The body of the function is entirely synchronous. The first line of code will run, followed by the second, and lastly, the third. It's very easy to understand the flow of our program's logic. On the other hand, we have asynchronous code. Asynchronous code will allow for multiple tasks to run. We don't have to wait for the previous line of code to finish running before running the next line of code. Take a look at this example. In the body, we are running a fetch function. The fetch function is asynchronous. A request's completion time can vary. It can complete within a few milliseconds or 100 milliseconds. We're not guaranteed that the request will complete within a specific time frame. This is common in JavaScript. There are functions that can take a while to execute. Rather than waiting for the request to be complete, JavaScript will move on to the next line of code. The final console statement will be executed before the request is complete. The question becomes, how do we identify asynchronous functions? In the resource section of this lecture, I provide a link to the documentation for the fetch function. The best way to identify asynchronous functions is by viewing the return value of a function. On this page, scroll to the return section. According to the documentation, the fetch function returns a promise. Functions that return promises are considered asynchronous. Promises are always asynchronous. In addition, promises will produce a value. You may be wondering, why is this important? Let's head back to our editors. We're using the fetch function to register a user. At the moment, the next line of code will be executed. However, that's not what we want. We should wait for the request to be complete. Otherwise, we may experience unexpected behavior. There's a feature for telling our function to wait for a promise to be resolved. Scroll to the top of the function for the event listener. Before the parentheses, add a keyword called async. The async keyword will mark a function as asynchronous. This keyword tells the language that our function will contain asynchronous functions. We can apply this keyword to regular functions or arrow functions. The async keyword must always be applied before the function. Let's head back to the fetch function. Before this function, add the await keyword. We're using a special syntax called async await. The await keyword will tell JavaScript to wait for the function to resolve. We can apply the await keyword to functions that return a promise. The next line of code will not run until the request is completed. That's perfect. We can safely assume that the request is completed before updating the registration form. Before we update the form, let's assign the value returned by the fetch function to a variable called response. By default, the fetch function returns a promise. Without the await keyword, the value of our variable will be a promise. However, the await keyword will force the function to return the value resolved by the promise. A resolved value is the value returned by the promise after the request has been completed. Let's head back to the documentation page for the fetch function. According to the documentation, the promise will resolve to an object called response. Let's click on this link to view the information related to the response. The response object will contain properties and methods related to the response from the server. This includes the JSON data returned by our endpoint. Search for a function called JSON. We're not interested in most of the information related to the response. All we care about is the JSON data. The JSON function will return the JSON data in the response's body. However, this function is asynchronous because the return value is a promise. The size of a JSON response can range from a few lines to hundreds of lines. The larger the response, the longer it'll take to process the body of the response. Therefore, this function has been marked as a promise. Luckily, we know how to deal with promises. Let's head back to the editor. After the response variable, define another variable called response.json. The value for this variable will be the response.json function with the await keyword. There isn't a limit on the await keyword. We can apply it as many times as we'd like. The response.json variable will hold the JSON data returned by our endpoint. It's safe to check the status of the response. After the variable, create a conditional statement. The condition will be the following: response JSON status equals 2. If the status property is set to 2, the user will be successfully registered. Let's update the signup_status.innerHTML property. The value will be a div tag with the following classes: modal status success. We are recreating the element with a different set of classes. These classes will change the background color to green. Typically, green is associated with success. Inside this element, add the following message: success! Your account has been created. After rendering this message, let's run a function called location.reload. The location object is defined by the browser. This object contains methods and properties for interacting with the URL of the page. We can change the URL or force the page to refresh. In this example, we are forcing the page to refresh. The user has been logged into the site. We should refresh the page to allow them to view the site as a logged-in user. We're almost finished. What if the user failed to register? Let's handle this scenario by adding an else block. First, let's enable the form. As it stands, visitors will not be able to modify the form. In an earlier lecture, we disabled the registration form after submission. We should give them a chance to amend their values. We can enable the form by removing the disabled attributes. Let's run a function called signup_fieldstate.removeAttributes. The removeAttribute function will remove an attribute on the selected element. In this case, we're removing an attribute from the field set surrounding the inputs. Let's pass in the disabled attribute to remove it from the field set element. Next, let's update the signup_status.innerHTML property. The value for this property will be a div tag with the following classes: modal status, danger. Inside this element, let's insert the following message: unable to create account. Please try again later. With that final line of code, we're finished. Congrats! The last step is to test our code. Save your changes and refresh the experimental page. If you're logged in, try logging out before testing the form. I've already logged out. After logging out, try submitting the registration form without filling out the fields. After a few moments, the message will inform us that the registration failed. The form will become enabled. We can freely modify the fields. After testing a failure, let's try creating an account with valid values. In a few moments, the registration was a success. The success message should appear temporarily. We won't be able to view it for long because the page has refreshed. However, if we look at the top of the page, the WordPress admin bar will appear. To the right, we're presented with our username. Perfect. We've successfully created an account and logged in. It took a while, but we've created a custom solution for registering an account. In the final set of lectures, we are going to start working on the login form. The process will be faster. The knowledge we've gained will be applicable to the login form. Once you're ready, I'll see you in the next lecture.